In the beginning, it would just look like finding the indefinite integral and then putting b in the answer, putting a in the answer and minus sign in between the two, cancelling arbitrary constant and getting the answer. But as we proceed further and further, you will understand better and better the meaning of actually doing this type of thing. You do have some idea already from physics background. Area under the curve, and that discussion will go one step ahead. So area, yes, but there is something more also which is related to the limits. When we find integral with a and b called definite integral, it has to do with some limit of sum also. Some limit of sum also. It has to do with area also. You already have the background of area thing from physics, and that will be extended more, and limit as limit of sum, that also will be covered later on. At this point of time, it would just look like find the indefinite integral. Don't bother about c because that won't come. And after finding the indefinite integral, put the limits, upper one first, lower one next, then putting minus sign in between. Right? So at this point of time, it is just this. We will also be doing many theorems, and using those theorems, you will see that how this procedure of finding indefinite integral is not required on many occasions. Somehow, using those theorems and results, things become highly simplified, and the elaborate process of finding integral by the methods that we have discussed, that is not required many times. Those theorems we'll be doing after this basic discussion and illustration, and after doing those theorems, many applications based on those theorems, and then those things will come: limit, area. So it is extension of integration discussion. Now you don't have arbitrary constant. Because of arbitrary constant, you could not be definite about your answer. Now that arbitrary constant is not there, so you are more definite about the answer. For a simple illustration, you can take any problem of indefinite integral. Maybe this one. Find the indefinite integral the way you do. No need to worry about constant. After integration, this is the way we put limits, not this way. Now put pi, put 0, put minus in between. Two by 5, you are done. So this is like doing a definite integral problem the indefinite integral way. Anyway, this was a very simple problem also. It was direct. But all those problems that we have done in indefinite integral, imagine doing them the way we have done them and then just putting those two limits a and b. That's it. But in that context, substitution method is worth mentioning. These limits are on the variable x. So suppose you make a substitution and x changes to t. Then if you write dt here, then t will not have these limits, may not have these limits, because x and t have some relationship. So if you write t here, you must change the limits. Just to give you a simple illustration, suppose I put x by 2 equal to t. That means dx is twice dt. And I make change here, and I make change here. Now, writing 0 to 2 is technically incorrect, because this was x equal to 0 to x equal to 2. And right now, it is t here. You need to look for the relationship. When x is 0, how much is t? That's what you need here. When x is 2, how much is t? That's what you need here. Then it's the usual procedure. In case of indefinite integral, we would eventually write x. We will eventually write the answer in x. Right? So once we make use of t, we eventually get back x. Here you don't have to worry about that. This problem is completely converted to this problem now. No need to go back to x. Right? Now sometimes you don't do a direct substitution for partial fractions, etc. You go for indirect substitution. So in those cases, limits won't change, because you are not really converting dx to dt. That's the meaning of indirect substitution. You're not converting dx to dt. Whatever you are substituting, it is for simplifying the thing in an algebraic way, etc. So when dx is converted to dt, then you need to change the limits. Regarding substitution, a very important point is that The substitution must be continuous in the interval of integration. The substitution must be continuous in the interval of integration. This problem is worth doing. If you do it directly, one upon a square plus x square formula, putting 2 by 2, putting minus 2, pi by 4. Okay? Now try this. When x is minus 2, when x is 2, minus of minus pi by 4. Eventually minus pi by 4. So why do answers do not tally? Because of continuity. In the second solution, when x is 1 by t, then this substitution rule is that important must be continuous, substitution must be continuous, substitution must be continuous in the interval of integration. Zero is there within the interval of substitution. 0 is there, and we are taking 1 by x equal to t. X goes from -2 to 2. So 0 is there within the limits. So how can 1 by x be taken as t? So the second one is incorrect. First one is correct, I by 4. Also, if you are integrating a positive function, 1 upon 4 plus x square, that's a positive function. Whatever is the shape of the positive function, definite integral tells us the algebraic area. Algebraic area can be plus or minus. But if the function is above x-axis, algebraic area is always going to be positive area. So the answer can never be negative for this. 1 upon 4 plus x square function is a positive function at all points. So plus pi by 4, that is the correct answer. Now, for the sake of doing all the types of problems that we have done in case of indefinite integral, they can be done by putting some limits, lower and upper limits, following those same methods. Since we have done them, that doesn't make sense to just put the limits, lower and upper, minus sign in between. And therefore, we are moving on to the theorems, which often simplify the job of finding definite integral. So we can say properties of definite integrals. All other things will work, which work for indefinite integral, addition of two, subtraction of two integrals, addition of two functions, integral of that, subtraction of two functions, integral of that, multiplication, integration by parts, all those things will work. First property or first theorem. It may look obvious and very simple, but it's very important. This theorem is very important. Let's say that this integral is capital Fx. I'm not using plus c because you know that c won't survive when you subtract. From indefinite integral, if you have t, then obviously the answer would be ft. Now when you put limits, then in this case it would be fb minus fa. And when you put limits here, then there also it would be fb minus fa. And these two are equal, and so are these two. Hence proved. Let me know if there is any question. Next theorem or next property. If you interchange lower and upper limits, then this is what happens. Proof, again, let's say that the indefinite integral is this, not using capital C. We know it won't survive. So when we put limits a to b, then it is fb minus fa. And when you consider this, this is fx, so it would be minus f of a minus f of b. fp minus fa. So clearly these two fellows are equal. Let me know if there are any questions. Next theorem or the next property. You can see that the two are equal. Both are equal to fb minus fa. You can introduce as many c's as you want. If on a number line I am putting a and b, you can have as many c's as you want. And you can have as many integrals as you wish. The condition is this: let me know if you have any questions. Next. Well, actually, first we will do a special case of this. And then we can do that A to B case. Look at RHS, this integral. Put this. What about the limits? When x is 0, t is a. When x is a, t is 0. F of t minus dt. So minus a to 0, ft dt. Minus sign reverses the limit. That means 0 to a, ft dt. But the first theorem that we did, inside the definite integral does not matter which variable you use, as long as it is homogeneous, x everywhere. But this is LHS. Any questions about this proof? Let me know. Now the general theorem. Method is similar. We start with RHS. We take a plus b minus x equal to t. So the differential dx minus dx is dt. Now when x is a, t is b. When x is b, t is a. F of t in place of dx minus dt. So we have minus b to a ft dt. But then we know that minus reverses the limits. So we have a to b, ft dt. We also know the theorem which says that inside the definite integral, which variable you write is not important as long as there is homogeneity. But this is equal to LHS, hence proved. Any questions? Let me know. Let's have an illustration. In the last step, when we say 2i, actually we are adding two equations. So I equal to this also, I equal to this also. Now add the two equations. That is this and this. Numerator you would see will be this plus this, which is same as the denominator. And that's why it becomes 1 dx. Right? Let me know if you have any questions. Try this one on your own. The hint is that use that a minus x property. Can you check your working? Now it is looking correct. If you would like this to be discussed on the board, raise your hand. When you use that a minus x property, in place of x you put a minus x. So that becomes this. Then log of cot x, in place of x you put a minus x. That becomes log of tan x. And similarly cos of 2 a minus x. That becomes cos pi minus 2x. And when you look at, when you convert log of tan to log of cot, 1 upon cot means minus log cot. So this is minus log cot, cos 180 minus theta, sine of 2 pi minus theta type of thing. 4 pi minus theta is same as 2 pi minus theta type of thing. So minus here also. 3 minuses will give you minus. Others are repeated. 8x, this and that. I equal to minus I or I equal to 0. Any questions? If you have, let me know. Yes. By I is equal to minus 1. No, I is not equal to minus 1. I is equal to minus I. Minus 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 will get you a minus sign. And then you will have 0 to pi by 2. Sine of 8x upon cos of 2x log of cot x dx. Isn't it same as this? That's why minus I. This is I. Yes, anything else? Try this. It's given that f of a minus x is fx. Now, what is the objective? Objective is to remove gx. Let's try that a minus x property again. Now why? Because I want to use gx plus ga minus x. Now I would like to add these. This is also I. This is also I. Now f of a minus x is fx. So when we add the two, but that is 2. It looks like that 2 is not coming. Let me know if you are getting anything different, or I will recheck. Looking at the private messages, some of you are getting 2. So I will recheck this. Those who are getting 2, can you recheck your working? Okay, now somebody was getting 2. Okay, now you are not getting 2. Okay, if anybody else who got 2 earlier, can you recheck your working? Whatever method you have employed, there may be many methods to do this problem. Check your working and see if you are still getting 2 or not. Alright, so that's the correction. Fine. There is no 2. There is no 2. And we stop now.